back. Continuing, so here is a summary of how to find a confidence interval for a proportion P. What are the requirements? Consider a binomial experiment with n trials, where P represents the population probability of success on a single trial. Q represents 1 minus P, that is the population probability of failure on a single trial. Let R be a random variable that represents number of successes out of n binomial trials. The point estimate for P and Q are following. P hat is R over n, Q hat is 1 minus P hat. The number of trials n should be sufficiently large so that both np hat should be greater than 5 and q hat should be greater than 5. Confidence interval for P is therefore P hat minus E to P hat plus E. What is E? E is Z sub C square root of P hat Q hat over N. What is Z sub C? It is a critical value for the confidence level C using our standard normal distribution. All right. So this is the summary to find confidence interval for P. Here is an example. Let's look at our flu shot experiment described in the textbook. Suppose there are 800 students selected at random from a student body of 20,000 students and given shots to prevent a certain type of flu. All the 800 students were exposed to flu and 600 of them did not get flu. Let P represent the probability that the shot will be successful for any single student selected at random from the entire population of 20,000. So notice the population size is 20,000. My sample is only 800. Let Q be the probability that the shot is not successful. All right. So question is to find the probability P that the shot will be successful. You see? All right. What is the number of trials N? What is the value of R? Each of the 800 students receiving the shot may be thought of as a trial. So N is 800 and R is the number of successful trials. So 600 people, students, did not get flu after receiving the shot. So this is 600 from the 800. So R is 600, that's the number of successful trials. What are the point estimates for P and Q? Well, estimate for P, the point estimate P hat is R over N, 600 over 8, that is 0.75. So estimate for Q is Q hat, which is 1 minus P hat, that is 1 minus 0.75. So P hat is 75 cents, Q hat is 25 cents, of course, yeah. So you can simply take away from 1 P hat to get this. All right. Now check for requirements. Is my sample size large enough? That is, are the number of trials large enough? So is large enough to justify a normal approximation to the binomial. N is 800. P hat is 0.75. Q hat is 0.25. So they are approximate values for P and Q. N times P, approximately, you multiply N and the approximation, you get 600, which is greater than 5. And N times Q, it should be a Q, is approximately 200, greater than 5. So a normal approximation is justified. Find a 99% confidence interval for P. Z99 is 2.58. How do you find Z99? Here is the confidence interval critical values. For 99% is here 0.99. Its ZC is 2.58. So using that ZC, you use your formula for E and you get approximately 0.0395. So the 99% confidence interval then is P hat minus E less than P hat plus E. So P hat is 0.75 minus the margin of error E, and here is 0.75 plus the margin of error E. So you found an interval 0.71 to 0.79. What is the interpretation? We are 99% confident that the probability a flu shot will be effective for a student selected at random is between 0.71 to 0.79. Okay, we are 99% confident that the probability a flu shot will be effective for a student selected at random is between 0.71 to 0.79. Which brings us to interpreting results from a poll. All right, we'll come to this in our next video.